So with that being said, we'll jump right into the pitches with our first company, Raj from Ateios Systems.
Hey everyone, Paul, thanks for the introduction. My name is Dr. Jean Kumar. I am the CEO and founder of Ateios Systems. Here at Ateios, we are building rapid, solvent, and forever chemical-free battery components, particularly the electrode. So, if many people know, if you look at a battery, it's mainly an empty can. The key component is called an electrode. It's a composite of powder coated onto metal foils. And right now, this battery, that component, accounts for almost 85% of the entire battery. So how we manufacture it, the materials we use, really impacts our ability to build a sustainable future. And right now, the technology that everyone is building these gigafactories relies on outdated technology that has not changed in 50 years, where we take these battery powders, we mix them in polymers that require high temperature toxic solvents, and then we use massive amounts of heat to remove that unwanted solvent. And if you look at a gigafactory, the ovens to remove that is almost 80 meters long and about 2 stories high. So it's about $30 million, and you're spending another $8 million to remove this unwanted solvent. So this process is just simply very expensive, very limited performance, and it uses all of these high emissions of PFAS. So we need a new solution that is much faster, lower cost, that can meet the demand. And that's what we're doing at Ateios Systems. So this is a technology that was developed by Oak Ridge National Lab. They came up with the concept, what if we use light instead of heat? If you think of all printing media, they use UV curing. That was the same idea. So Oak Ridge developed a polymer that is a liquid state, and you can coat it, mix it through traditional manufacturing, but you convert it into a solid film just with exposing light. And what that does is it eliminates all those expensive solvents and basically almost zeroing the capex and the opex. And what that does is literally shrinks the gigafactory to a fraction of the size. But you're seeing benefit of cost reduction, you're seeing the ability to increase energy density, and it's using no PFAS and near zero emissions. So this is what competitive analysis looks like. So if you look at the incumbent manufacturing, roughly 150 per kilowatt, 100 micron thickness, and manufactured at 60 meters. This technology will see that nearly 30% cost reduction. You can do much thicker electrodes, and you can almost see a 5x increase in production, while no retooling of the gigafactory and no forever chemicals. Other companies have been trying to solve this problem. Tesla was one of the first movers on their dry electrode. They still can't hit the demand or the speed and demand. And there are other emerging solutions that are trying to solve this without PFAS. The main takeaway is that our process is first to market. We are at a high TRL, and we're solving all those problems on production, the regulation, and cost. And so kind of shifting to the market focus. So we've got this really exciting platform tech. The question is, where do we go, right? There's so many types of battery chemistries where, in terms of chemistries, the entire lithium-ion battery market, from little IoT batteries to power drills to cars, is roughly $85 billion. And the components are roughly $70 billion. The question is where to go first. We are targeting these consumer electronics. These are devices that you see in your phones, laptops, where they only need 1-2 year warranties, and they make up 33% of the entire market. So that's the biggest market, with the least technical risk. We want to start there and allow us to beachhead and get into those EV markets. And how are we going to do that? So I think this is a challenge that everyone's been talking about in battery space, is in order to build a gigafactory in the US, it costs $146 million per gigawatt production. So it's really hard to go to an investor and say, hey, I don't have the orders yet, I need 146 to supply that. So we've actually validated one of the first truly fabless models, where what we did is, instead of trying to manufacture each component ourselves, we worked with toll manufacturers like Kodak. We plugged into their assembly line, and then we're actually now selling our electrodes to partners in Asia and the US to deliver to customers. And so we actually now have the capacity to produce 10 to 100,000 cells a day at price parity on a global market. And actually, this past July, with the ChargeUp team, we actually released one of the first PFA-free battery electrodes. We worked with Illuminate and helped get that press release. and also working on the marketing. And what we're showing is better energy, cost reduction, and a PFA solution. And what was really cool is we actually gave sample packs to battery owners off the production line. And then we gave all the SOPs so they could replicate our results and see if they want to purchase Cohort. And so this is the traction we built in that time. So we have shipped samples to those customers there. Custom Electronics was actually a company we got connected through ChargeUp and able to sell them a pack. And we're now talking about delivering orders to batteries to companies like Soft Matter and the DoD. And we now have active conversations with Tesla and SK to do paid pilots. And we're also looking to get larger SKUs to target like Microsoft, Meta for a PFA solution. So what we're actually now trying to do is raise $8.5 million. We've been able to generate a significant amount of revenue just through DoD grants. What we'll do with Kodak is that by retrofitting their line, we can produce over $400 million of battery product just from that single line. Here are our future kind of funds and future milestones. We want to hire a VP of manufacturing, a senior salesperson to help convert those enterprise sales. We want to make those small CapEx investments at Kodak. And we also want to expand our product line into the mobility and larger circuits where just with 3 chemistries, we can have 85% of the market. So I think I've talked before, one of the key reasons to our success is we really developed that incubation model. Back in 2020, we incubated at the Battery Innovation Center. That has allowed us to get access to all the supply chain, all the production equipment, where anytime we develop something and optimize it at the BIC, it automatically translates immediately at Cohort. So validating that really speeds up development and reduce costs. And then, And lastly, myself, I'm from upstate New York. I went to SUNY Albany. Went all over the world, in the U.S., kind of really learning how to build a battery company. And obviously, I'm hoping to see if I'm back. Our CEO, Thea Reed, she also studied at SUNY Albany. So, I think we've built, our dream is to come back here and build a company here. And then we have Matt Pinkman and Dr. Tim Berry leading our sales and engineering. A really complete team. Each person has real hands-on experience manufacturing batteries, and that's a real value that we offer to our customers and owners. So, thank you, everyone. Here at Ateios, we're developing solid-free electrolysis that's going to enable sustainable growth. Thanks.
Thank you, Raj. Next, I'd like to introduce Ray from Fermi Energy. Great.
Hi, everyone. This is Ray Xu from Fermi Energy. Thanks for spending the next 10 minutes with us to learn more about Fermi. So I'll be presenting Fermi's advanced cathode technologies for rechargeable batteries. So at Fermi, we are innovating and also manufacturing cathode active materials for lithium-ion batteries that are both nickel and cobalt free. And we have 3 main features, one being the cost reduction, because we don't use those expensive nickel and cobalt in our product. We instead use low-cost elements such as manganese and other low-cost elements to make those batteries. Second one being the fast charging capability. So we are enabling sub-10-minute charging for EV batteries. So imagine about that, you have an EV, and if you spend like more than 1 hour at the charge station, you might not be able to, you just don't want to buy the EV, but we are solving this problem for our customers. And last one being the low temperature performance. So if you have a battery that can only maintain 50% of its capacity at winter time, will you still want to buy it? Maybe not. And we are developing this new chemistry that can maintain more than 80% of its capacity at minus 20 degrees Celsius. This temperature is essentially even lower than your freezer's temperature. So, yeah, a freezer has like minus 18 degrees Celsius. This is minus 20. So, why we want to get rid of nickel and cobalt? The reason being just very simple. They are very expensive. So if you look at this diagram, you can see the battery packs is about 40% of EV cost. And if you disassemble each individual cell, you can see the cathode component here is about 51%. I guess there is some like format issue here. but this cathode component is about 51% of the cell cost. And those two minerals, cobalt and nickel, they account for 3/4 of the cathode material cost. So if you want to reduce the battery EV cost, you have to get rid of those two minerals. And another reason is more like specific to the US. So here is a diagram showing the distribution and the mining of those nickel and cobalt. So the green is the nickel and the pink is the cobalt. You can see these two tiny dots. I'm not sure the audience can see those two tiny dots, but this is the reserve and also the mining we have on the US land. So the percentages for nickel is less than 0.11%, and cobalt is about less than 1.75%. And that's why the US DOE has laid the goal to eliminate both of the minerals from the next generation batteries by 2030. So globally, we already see this nickel shortage because there's more adoption of EVs and the nickel consumption rate is really like skyrocketing these days. And based on Bloomberg report, by 2040, the nickel deficit rate will be more than 30%. And if we don't use nickel and cobalt, we actually have other chemistries, such as the lithium iron phosphate. To be honest, this chemistry is perfect. This is great. It has like really stable cycle life, really good for EVs, but it has like three intrinsic problems. One being lower energy density, meaning that for typical EV charging, you can drive less than 300 miles. And the second one being the fast charging capability. So LFP chemistry typically, people just cannot do the fast charging because of chemistry itself. And the last one being the low temperature performance really poor. So at winter time, you can maintain less than 50% of its capacity. So at Fermi, we have developed this new chemistry. It's kind of weird, the format has changed a lot. But for the cost side, our new chemistry, the cost is similar as lithium phosphate, which is a low-cost version of the state-of-the-art cathode active materials. But we can increase the energy density by 30%, and meaning that instead of I can drive 300 miles with this chemistry, you can drive close to 400 miles per charge. And the low temperature performance is much improved, meaning that in winter time, instead of like worrying about whether you can go home with this EV, and you don't have to worry about that because we can maintain more than 80% of its capacity at low temperatures, such as -20 degrees Celsius, which I guess is the lowest temperature you can experience in the US. And the last one be the fast charging capability, which I personally believe this is the best one for this feature. We can reach sub 10 minutes, and we have tried 6-minute charging. We can charge to 80% of its capacity by doing 6-minute charging. And we have been testing those battery cells in pouch cells. Actually, those cells were assembled in Professor Stan Whittingham's lab. So these are the cells we assembled at BU, and then we brought them home in Virginia to test them. And these are the performance we have reached. And here's people are asking like about the competitive landscape. Actually, we did a very extensive analysis of our market, and there are hundreds, if not thousands, of competitors in this domain. And here I only list like a few of these top players here, and you can clearly see we have like the high cost, the high performance ones. I just want to clarify on the top right, that's not us, that's just the logo. But that's our future goal. That'll be best. We can reach the lowest cost and best performance. But that's just future milestones. But you can see for this nickel-rich ones, they have high cost, high performance. Some of the cobalt-based, like high cost, slightly lower performance than this pure, like high nickel ones. We also have this lithium phosphate. They're on the lower cost side and lower performance. We also have some competing technologies such as iron air, sodium ion, or lithium sulfur. They claim to have the lowest cost, but also the performance side is like on the lowest side. And here we are proposing like lower cost but slightly better performance than this lithium phosphate chemistry, and that's how we are going to compete with these competitors. And we are a materials manufacturer, so we make those cathode powder and then sell to potentially Ateios, who has been making these electrodes, and we sell the powder to them, and they will be making the electrodes and then make the final cells. So we're about 2.5 years old now, and in the first 2 years, we have achieved multiple milestones here. You can see, and right now we are doing the product development together with our customers. And next step will be building a pilot scale production line to do the cathode powder production. And year 6 will be starting selling the cathode materials. For the next steps, we have the plan to raise a 2.5 million pre-seed round, and we want to establish the pilot scale production facility, and we will be hiring engineers and business development professionals to help us grow. And this is basically will help us reach the stage of 1,000 kilograms per month, which will be enough to support our existing customers in the defense and also the satellite domain. And in the future, we'll be tapping into the EV sector, and that will substantially increase our revenue and also profit. So we are a pretty young company compared to some of the other Cohort members, but we are very lucky to have received multiple funding grants from DOE, SBIR, DOE RPRE, DOE MTO, and also SF SBIR, Army SBIR, this different funding agencies. So we're very lucky to receive this funding. We also participate in multiple training programs, including this great ChargeUp program. We're very grateful for this participation. We also maintained active relationships with our potential customers. And during this ChargeUp program, actually, Panasonic Energy visited us twice in Southwest Virginia, Blacksburg, Virginia twice. We were very lucky to have them visiting us. Some of the team members fly from Japan to our site to learn about our technology. So we're very lucky to have support. We actually received the training during their visit, before their visit, to learn how to talk to them. So that's very great helpful. And here is the management team, my co-founder, Dr. Feng Li, and myself. Together we have more than 25 years of experience working in the battery domain. And we have this different advisors, both in business development. Dr. Amers, 30+ experience in the business development, and Dr. Mark Adolf, she just recently retired from Berkeley National Lab, and she joined as our advisor. We also have legal support. And I'd like to thank you for your time to learn about Fermi. And I'll be at the first floor, and if you have any questions, feel free to catch up with me, and I'll be giving more details. Thank you.
Thanks, Ray. You took my closing about downstairs, but anyways, I'll let you. Thanks again. Next, I'd like to introduce Madi from MITO Materials.
Thank you, Paul. Our doomsday clock is at 90 seconds to the midnight. And I know everybody here knows about that, and that's why we're sitting here, because we know how dire our situation is. That being said, it still should be very interesting to us, considering every being that is walking on this planet born with one very simple instinct: survival. And we continuously ignore that. I'm here to tell you about MITO and how MITO tries to help the sustainability story through innovation. My name is Mahdi Ghazadeh. I'm President and Chief Operating Officer at MITO Materials. And the two pillars of sustainability that we focus on are gas emission, greenhouse gas emission, and also looking at the other component, which is, if I can get my clicker work, circular economy and recycling the plastics that are circulating in our ocean. Now, that's a really handful of sustainability through innovation. What does that really mean? For us, it's really making additives that are very targeted, very multifunctional for the application that are being developed for. Again, very handful of words. What does that mean? It means that we identify what our material needs to do, and then we develop it. The simplest way to explain it is really what my 6-year-old does with his Legos when he's trying to make aliens. He just starts putting blocks next to each other till he gets to whatever he is looking for. And usually some weird stuff that you can expect from a 6-year-old. But in the science, this is really what translates into. You start with something as simple as graphene. Apologies for saying simple. And you start adding material to it, and you get to something like the image that you see at the bottom. That's one of our commercial products called Ego. The bright dye that hopefully you can see on this screen are the additional material that is built on it for its specific application. This is really the build-out Ego. It starts with graphene oxide, added what you're just calling it linker at this point for trade secret aspect of it, adding silicon to it, adding an epoxy resin to it, and you get basically the final product, which can improve mechanical performance, thermal performance, electrical conductivity, fire resistance, and pretty much a lot of other things, and that's the goal. These are the other two materials that we have, pretty much like Legos. As you swap things, you can actually make new material, you can make new innovations that can be targeted for a specific application. For example, Acre, our second commercial product, is a starch-based. It's a bio-based material that can degrade in our after use, which is ultimately one of the goals for our additive, is to be biodegradable when they're being used. The other example, Lycra, that's a graphene that is made out of carbon captured machine. What does it mean is that it actually carries carbon negative effect when it's being produced. Now, what is really additives? For those of you who are just wondering. It's the easiest way, again, to explain it is probably saying it's the seasoning on a steak. It's not the meat itself, but without it, it's just something missing. It's not steak. Additive is a 200+ billion market. From that, plastic itself is around a quarter of that. If we really focus on just one of the verticals that our company is engaged in, which is carbon fiber composites, and we take 3 of the different areas that we're active in it, that creates a almost $5 billion TAM for MITO. Where does this additive goes in your car? Pretty much everywhere. Everywhere that there's polymer, there's the plastic, our additive can go into and provide different type of improvement and performance. Now, if you have a solution that can make those carbon fiber perform better, what does that translate into? How is it helping the sustainability? By redesigning the same product and getting the material out of it. So you can really make the same part, the same performance with less material. 20% less carbon fiber, which essentially translates into 38,000 metric ton of carbon fiber capacity. Now, this is just one of the examples of the use of our material. What you're seeing on this first graph, basically, is the recycled carbon fiber being added to a PA6 nylon, plus our additive, and being reused, flatized, and then being used in making different parts for automotive. And the reason you can do that is because it improves the mechanical performance of the material. Now, again, how do we quantify what that means? It really means that you can save a lot of CO2, or take a lot of CO2 out of the atmosphere. This is really a snapshot of our roadmap and where we want to go and where we are today. We are quite been lucky in the past 2-3 years to be really well established ourselves in the area of carbon fiber, in the area of composites. We have a pipeline of more than 100 companies, 24 of them very close, they're in pilot. We have more than $8 million in MOUs. We haven't reached the 1 million sales yet, but we're working around that. And the goal is ultimately to really get to one of the largest market that we think our material can improve the performance, and that's the battery. And that's really why we joined this program, to really know if we wanted to take on that journey, who can be our partner, where are the networks, where are the key points, where is the supply chain, and things like that. There's a lot of smiley faces here, but the thing that I wanted to show here is really, we have a very diverse team, from a women-led and founded company to very well-seasoned, been around, very extensive experience, former CFO of Avient, which is one of the largest chemical company out there, from a former CEO of another startup who has gone through our journey, who has ultimately exited from that startup, selling that to Henkel, which again is another big chemical companies. In addition to those, we actually have industry advisory board, which are people who are either good, one of them in graphene, the other one in composites. There's a third seat that is still open, and we are hoping that will be basically a battery advisory. We still have a note round open. The initial round was for 2.5. We oversubscribed to 2.7 and extended it to 3 million at this point. The last drop that we are looking for is really to be focused on development of the solution for a battery. So that 300K money coming in, which at this point is really de risk because it's the last money in, is really going to be used for development of the battery in the near state. If you have any question about MITO and its journey, and you want to learn more, I'm more than happy to talk to you later, or you can simply just shoot me an email. Thank you.
Thank you, Madi. And finally, I'd like to introduce Andrew from Standard Potential.
Alrighty. Yeah, thanks for coming, everyone. My name is Andrew Wang. I'm the co-founder and CEO of Standard Potential, and we're commercializing terawatt-hour scalable sodium-ion batteries. So really excited to tell you about that today. So did you know that 40% of a gigafactory is actually used just to charge a battery up for the first time? This is a process that's called formation, and it accounts for, in an average gigafactory, we're talking about $1.5 billion in capex for equipment, about 20 football fields in plant area. And the reason why it takes up so much space and costs so much is that it's an excruciatingly slow process, so 2 to 3 weeks, a massive bottleneck in the overall gigafactory design. And so we thought this was kind of insane because you get your phone, you get a new phone, it has a battery. The first thing I do is plug it in and charge it up anyway. So why are we doing this in the factory? And so we looked at this and saw an opportunity to eliminate the need to do formation within the gigafactory. And so the technology we're commercializing that we're dubbing Freeform is our proprietary sodium-ion technology, which is a process that eliminates the need to do formation in the gigafactory. And so we would like to just sort of walk through why we need to do gigafactory formation today. Really, in today's lithium-ion and sodium-ion processes, the moment you assemble a cell, once that's assembled, its natural state is actually down at 0 volts. And that's a voltage where you have a lot of corrosion reactions that compromise the performance and safety of the batteries. And so the moment you seal up a battery, you're in a race against time to charge it up, get it off for 0 volts, and begin all the different formation steps like clockwork. And so it's a complicated, time-intensive process, but also requires multiple different sets of power electronics. And so that's really what's adding to the cost as well. Our technology stabilizes sodium-ion batteries down at 0 volts, which allows us to sort of reimagine how the formation workflow actually happens. So Being stable down to 0 volts allows us to deploy safely at 0 volts and allows us to choose when, where, and how that formation occurs. What's really interesting about that is we're able to develop new formation protocols that can squeeze 5 to 10% extra energy out of the battery without changing any of the chemistry. We can also change that formation process that takes, from an order of days to weeks down to hours. And so we really see this as a transformative approach to deploying and scaling sodium-ion battery technologies in particular. The overall sodium-ion battery field itself is actually at a commercial inflection point as well. And really what that means is that, across all the different battery chemistries, we see sodium-ion as being the most exciting, fastest improving in this segment. And so we're talking about energy densities that are already approaching the low end of lithium-ion, durability that already sits between where NMC and LFP is today. In fact, durability and cycle life has doubled in the past 18 months. And even today, you're getting benefits in terms of safety, wider temperature operation, particularly down at low temperatures. And of course, sodium is a sustainable and abundant mineral. So lithium carbonate, which is the critical mineral used in all our batteries today, is controlled, the supply chains are really just controlled in just 4 countries. So this is actually a supply chain that's more concentrated than OPEC. Sodium carbonate, on the other hand, the US is actually the single largest natural producer of sodium carbonate per year, which is about 10 terawatt hours worth of batteries that we've been making this. And so this is all the momentum that sodium ion as an entire industry is currently riding on. Freeform as a technology sits on top of all of that. It allows us to unlock more energy and efficiency out of every single cell, gets techno-economics down into the longer duration segments, which are really important for stationary storage, adds an additional layer of safety down at 0 volts for operations, and instead of being just compatible with existing gigafactories, we actually simplify the amount of manufacturing you need to deploy. So this is a process that we already scaled 10,000 times from a tiny lab watch battery onto these 10 amp hour Red Bull sized, soda can sized cells that we'll be demonstrating downstairs. And we've also validated this across multiple different flavors of sodium ion chemistries as well. So our business model is really to focus on optimizing our free formation process. And what that means is that it allows us to work with existing upstream manufacturing capacity to sort of scale this in a CapEx-like fashion. And as I mentioned before, because freeform is a process that is compatible across sodium-ion chemistries, this puts us in quite a unique position in that we're able to actually work well across the landscape of innovators that are really targeted at materials chemistry-related innovations in the sodium-ion space, and best connect those technologies with the module and pack integrators that are going to be deploying these out into the world. So that's our first phase of our strategy, is to really validate, sell a direct sodium-ion battery out into the field to validate our freeform process. From there, we'll then partner with gigafactories, jointly scaling, applying our process to amplify their output as well. We're starting with 12 to 48 volt batteries in the micromobility, lead acid replacement, industrial equipment like forklifts, and this is a segment that we already have a kilowatt hour level of purchase orders that we're currently fulfilling. From there, we'll be growing towards the large utility scale grid storage segment, where the actual intrinsic performance capabilities of sodium ion actually lend particularly well towards the 8 to 16 hour duration segment. So this is something where sodium ion is already compatible in the same voltage ranges of lithium ion, same form factors, so it's compatible with the hardware infrastructure, but it provides economics across a longer duration, so it allows for a differentiated product on the grid. This is the co-founding team. So Rich and I actually co-led the development of this technology as part of a Department of Energy ARPA-E research program. I'm also the previous co-founder of Intercalation Station, which is a battery newsletter and consultancy that we did due diligence for VCs investing in the battery space. We also had our own angel syndicate supporting early stage startups as well. Rich and I actually started our careers together about 7 years ago on the Tesla cell engineering team validating the original Model 3 chemistry. And together we have also assembled a co-founding advisory with over 15 gigawatt hours per year of manufacturing experience across the US, Europe, and Asia. And collectively we've seen just how hard it is to scale gigafactory manufacturing, right? And so It's made us really excited about this innovation that we're bringing to market today. So I just give a shout out to the ChargeUp program, Paul, Vandana, the Illuminate folks. It's been a really great 6 months. I think, we were fresh out of our, government research program at Columbia when we joined the program. So we had, whatever dollars ChargeUp gave, those were the dollars that we had to our name. We've now raised over $1 million in non-dilutive and are about to kick off our pre-seed round. So if you're an investor in the room, we should chat downstairs. But to everyone else, depending on if it survived the ride up from Westchester, where we're headquartered, we'll have a phone charger running on sodium ion, so you can swap your lithium-ion phone battery for some sodium ions. If you are a purchaser of cells, if you buy lithium-ion cells, if you work with lithium-ion cells, we should talk about how sodium ion could be expanding what products you're putting them into. If you work with gigafactories, we already have one qualified partner upstream. We'd love to chat about building that model out. And overall, let's talk about how sodium ion can provide safer, sustainable energy storage. So thanks for your time.
Thank you, Andrew. Kudos to them. They all stayed on time, so we didn't run over, so appreciate it, guys. So on behalf of Vandana Katosh, myself, the Illuminate partners, and like Andrew said, all of the ChargeUp program team that supported this program throughout the 6 months. Thank you guys for your dedication. It was fantastic. Shameless plug, we will be opening applications for cohort number 2 on Monday, October 28th. So spread that news. And so at this time, like Ray mentioned earlier, everyone is invited downstairs for networking. All of our ChargeUp companies will be tabling, so you can engage with them, ask them any questions, make some great connections, and have some food and drink. So thank you all so much for coming. I appreciate it. Enjoy the networking session.